Hey guys, how's it going? I just thought of a neat video to make, so I'm going to make it. It's starting to get semi-warm here in Ontario, so I'm going to start running this 24/7 again. I might do what I did last summer and hook it directly to the solar panels, and the excess power will go into the grid and batteries, and this will only run during the day, or I may try to run it day and night. If I do that, though, I'm scared it will actually freeze the beer or whatever else I have in here. I put nice shrink wrap over all my connections, except for this one. I ran out of shrink wrap for this one. I doubled up my output cables on this battery bank. I have a negative and a positive from this side, and a negative and positive from this side going into my battery bank, my bus bar, which is fine because I have one cable going off into this direction, one cable going off into this direction. So I have two cables coming off this, one on this side, one on this side. This one should drain pretty evenly between these two. And I have it on. All my battery bank is on. We're hovering around 13 volts with this thing running. But that's not the point of this video. The point is to put close to 100 amp load. I'm going to test individual battery banks. This one, and the 1, 2, 3 different battery banks that I have on switches. I want to test the voltage under 100 amps. I want to see how evenly the load is distributed. So I'm going to go ahead and turn my load on. Just right there. Approximately 1,000 watts. I think one's 500 and one's 300, so maybe more like 800. This is only saying, what's it saying here? 680, 690. It's a little off. I think it's closer to 800. But anyways, voltage is instantly down to about 12.5. I'll probably settle at around 12.45, something like that. And that's what it's going to stay at. Got my voltmeter here. We're going to test the main big battery bank here. Just going to find a way to just stick it under the shrink wrap. That's what I'll do. I knew I put it on for some reason. Alright. Here's the main big battery bank. 12.54. We're down to 12.47, and that's off the bus bar inside. So there is still losses in the lines. This is the big 405 amp hour battery bank. This is the bus bar. Now let's check. This is just a bank of a 55 amp hour and a 35 amp hour. It's just extremely sloppily put together just so I can use it. I had to take it apart. Didn't have time to do it again properly. I really got to do that, I know. But let's check it out and see what's going on here. Wish I could get a good connection here. There you go. So 12.53. Yeah, it's about the same difference. Okay, so that's good to know. It's because these are all external batteries with wire running into the bus bar. Let's try these recovered sealed lead acid. These were so dead when I got them. What are they holding at? 12.44, 12.42. The problem I find with recovered batteries and adding them to your system is these really don't help out until about 12.4 volts. That's where these batteries like to hold their load, where the better batteries, like even these ones, but the brand new ones over there, they will hold at 12.6, 12.5 volts, something around there, for most of their duration. So anyways, now we're going to go into the battery bank. So this is just something I made up a long time ago. There's one bus bar that leads on one side to the other. It's just a crush down copper pipe. Same with this side. I have all kinds of wires and a mess of stuff running. So let's check some of these other banks. This is a 55 amp hour battery. Let's check that one. See if we're evenly going down here. It's not the easiest thing to do here. I'm not good at testing these things. Do what some people do. There you go. 12.64. Wow. That was way up there. I still have the same load. 12.64. That's crazy. That one has is holding the most and the highest. I guess that's resistance in the wires that I'm using for that. I am using 3 of these, I don't know, 6 gauge wires on each lug here. 1, 2, 3. 1, 2, 3. I thought that'd be plenty, but apparently it's not. It's the first time I've done this test because my battery bank is growing to the point where I actually got to keep an eye on it now. 12.46 on this one. This one's only got 1 set of 6 gauge wire. Okay, so that is interesting. So that I'm learning already. And then here's underneath all these mess of wires, I got 7 amp hour batteries, and I'm just gonna test them just to see what it's got. They all got 6 gauge wires as well. Oop, had it. So they got more than enough. 12.47-ish. What's my main bus bar have? 12.41. That's what I'm hovering at right now. So, my cell phone is dying yet again. And we'll test these one more time. These main ones. I believe I do have enough of this, enough wire connected to these big ones now. 12.47, 12.41. It's hovering about 0.1 of a volt-ish above. And that seems sufficient. I seem to have enough cabling and wiring for this battery bank now. There seems to be one inside the case. The 55 amp hour could use heavier gauge, but other than that, it's actually the load is fairly equal amongst them all. I'm surprised. And this is with a 10 amp cooler, and if that meter is 100%, which is not, it's showing around 700 watts. That would convert to around 70 watts DC. So that's including that's 80 watt load. It's probably more like, with the efficiency, maybe 90 amp load. I keep saying watts, but it's amps. So used to it. At the inverter terminals, 12.21, and at the bus bar, 12.41. That the cabling is definitely not sufficient. I have 2 gauge cable. Definitely could be thicker, or at least shorter. I have a little bit coiled down here. I think it's 36 inches long, which is obviously too long. I'm dropping 0.2 of a volt, which is too much for me. I don't like that. That means I'm gonna run out of power when my battery is saying emergency, and I don't care about state of discharge. All I want is power. I don't care if my batteries get slightly damaged. It's an emergency. I need power. At 11.2 volts, it's going to cut out instead of 11 volts because of loss in that inverter's cabling. That's only at high loads, but still, that could mean the difference between me keeping my food good long enough in a power outage, or my furnace running in the cold. But I am enjoying this hobby, this adding batteries and solar. It's a lot of fun. You just got to be careful. Got to keep things fused. Another thing I just got actually is this this power strip. It's nice. I got a lot more plugs. Obviously, you can't put 1500 watts on each one. It's only rated for like 1800 watts total. So just got to keep that in mind when using it. And I freed up some space here. I'm not sure exactly what I'm going to add there. Maybe I'm going to add some fuses, some DC fuses, or some breakers. I have a few breakers. I can take this one off. I'm not using it at the moment. I disconnected it. I got another DC breaker up here for the grid ties. And I have all these breakers here. These were built into this thing, so I decided to use them. So, what's this one? This is a 30 amp breaker, 7 amp breaker, 5 amp breaker, and a 20 amp breaker. So I believe I'm using the 30 and the 20. And I don't think I'm using the small ones right now because I don't have a need for a breaker that small. But that's it. That's my setup so far. Still running the lights. I like it. Thanks for watching, guys. I'll keep updating as my system grows.